In this video, we're learning how to solve trig equations on the interval 0 to 2 pi. And if you look at our screen, you're going to see I have this little unit circle on the right side of our screen. So I'm going to be using the unit circle to solve these equations. So if you haven't already learned the unit circle, I encourage you guys to learn that before watching this video. So let's jump into example 1, which is 2 sine x plus 3 equals 4. So we're trying to solve for x. So what we want to do first is isolate sine of x. So to do that, first we want to subtract 3 from both sides of our equation. On the left, we're going to be left with 2 times the sine of x. And on the right, 4 minus 3 is 1. And now we want to divide both sides of our equation by 2. We're left with sine of x on the left. And on the right, we have 1/2. So now we're basically trying to figure out where is the sine of x equal to 1/2 on our unit circle. And remember that on the unit circles, or on unit circle, our x-coordinate is equal to the cosine of our angle. Our y-coordinate is equal to the sine of our angle. And y over x is equal to the tangent of our angle. So this is going to be useful for these problems. So because we're looking at the sine of x is equal to 1/2, we're basically trying to answer the question, when is our y-coordinate equal to 1/2? So for what angle? So we're trying to find what angles have a y-coordinate of 1/2 on our unit circle. And we're in radians because we're on the interval of 0 to 2 pi. And what that interval means is we're just going to be looking at one rotation of our unit circle. So now what we're going to do is we're going to go over to our unit circle and we want to figure out what angles have a y-coordinate of positive 1/2. So if we look right here, this angle has a positive y-coordinate of 1/2, and that angle is going to be pi over 6 radians. So one of our answers is going to be x is equal to pi over 6 radians. So we're always going to get angles for our answers for these problems. And then we're going to have one more. So we're going to go over to our unit circle and we're going to look. And we look right here, we have a positive 1/2 as our y-coordinate, and our angle is 5 pi over 6. And those are our only two answers. There's no other positive 1/2 y-coordinates. So we get x is equal to pi over 6 and 5 pi over 6 as our answer. Let's go through some more examples. So example 2 is tan squared x minus 1 is equal to 0. So again, our goal is to get tangent of x by itself. So first we want to add 1 to both sides of our equation. On the left, we have tan squared of x. On the right, we have positive 1. And now this is really the same as the tangent of x, this entire thing squared. So you can think of it like this. So to get rid of the squared, we have to take the square root of both sides. On the left, we're going to be left with the tangent of x. On the right, we have the square root of 1, and you have to remember to put a plus or minus in front of there. So when you're taking the square root of both sides of an equation, you need to put a plus or minus in front of your answer. And then the square root of 1 is just 1. So we get the tangent of x is equal to plus or minus 1. I'm going to break this up into two equations. So this means that the tangent of x can equal positive 1, or the tangent of x can equal negative 1. And remember from our last screen that the tangent on the unit circle is equal to y over x because it is equal to sine over cosine. So what we're trying to figure out is when is y or x, I'll write it here, underneath here. When does y over x equal 1 or negative 1 on our unit circle? And what that means is that y has to equal x, because then y over x is 1, or y has to equal negative x. So basically, x and y have to be the same coordinate, or the same coordinate with opposite signs. So I'm going to show you guys what I mean by going to our unit circle. So if we look at our unit circle and we look at this angle right here that has the point root 2 over 2, comma root 2 over 2, I'm going to show you guys what happens when we do y over x for that point. And that angle is going to be pi over 4. So if I wanted to find the tangent of pi over 4, I would take the square root of 2 over 2, that's my y-coordinate, put it over my x-coordinate of the square root of 2 over 2. Anything over itself, right? So the square root of 2 over itself is going to be equal to 1. So I know that the tangent of pi over 4 is equal to 1. So one of my answers, I'm going to write it down here in yellow, is pi over 4. And now I want to figure out where else are both of my x and y coordinates the same. So if we go down here to 5 pi over 4, our x and y coordinate are exactly the same. So we know that when we take the tangent of that, we're going to get 1. So another answer is 5 pi over 4. And now what we need to do is figure out, well, when are our coordinates pretty much the same but different signs? So if we look up here at 3 pi over 4, we have negative root 2 over 2 and positive root 2 over 2. And I'll just show you guys what the tangent of this is by actually writing it out. So the tangent of 3 pi over 4, again, tangent is y over x. So it's going to be root 2 over negative root 2 over 2. Anything over itself is 1, but the numerator of our fraction is positive and the denominator is negative, so this is negative 1. So the tangent of 3 pi over 4 is negative 1. So that's one of our answers because we are also looking for when the tangent is negative 1. And now we're going to have one more answer. If we go down here to 7 pi over 4, we have an x-coordinate of root 2 over 2 and a y-coordinate of negative root 2 over 2. So when we do y over x, we'll get negative 1. So we also get 7 pi over 4 as an answer. So we got 4 answers for this one. Let's keep going through some more examples. So for example 3, we have this factored equation. We have the quantity of cosecant of x plus 2 times the quantity of cosecant of x minus root 2 is equal to 0. So what we want to do is set each factor equal to 0 and solve them separately. So we're going to say the cosecant of x plus 2 equals 0. And the cosecant of x minus root 2 is equal to 0, and we're going to solve each equation separately. We're going to get some different answers for each one for our x values. So for the left equation, we're going to start by subtracting 2 from both sides. So we get the cosecant of x is equal to negative 2, and on the right, we're going to add the square root of 2 to both sides of our equation to get that the cosecant of x is equal to positive root 2. And now I think it's easier to change cosecant into sine. So remember that cosecant and sine are reciprocals. So this is the same as saying the sine of x is equal to the reciprocal of negative 2, which is negative 1/2. Or the sine of x for this right equation is equal to the reciprocal of root 2, which is 1 over root 2. And now let's get this root out of the denominator. We're going to multiply the top and bottom of our equation by the square root of 2. So this is really saying the sine of x is equal to the square root of 2 over 2. And remember that on the unit circle, sine is equal to the y-coordinate. So we're trying to look for angles where our y-coordinate is either negative 1/2 or root 2 over 2. So let's do negative 1/2 first. So because our y-coordinate is negative, we know we're only in the bottom 2 quadrants, so quadrants 3 and 4. So we don't even have to look at the top 2 quadrants when we're solving sine of x equals negative 1/2. So if you look on the unit circle, for 7 pi over 6, our y-coordinate is negative 1/2. So we know that's one of our answers. So we'll write x is equal to 7 pi over 6. And then a shortcut for finding the other angles is that when you are solving either of the equations, like sine of x is equal to 1/2, your 2 answers, or however many answers you get, are going to have the same denominator. So when we're looking in the fourth quadrant, we only want to look at a denominator of 6, so 11 pi over 6. This has a y-coordinate of negative 1/2. So that's going to be our other answer. So that's just going to save you guys some time so you're not looking through every single angle. We'll do a similar thing for sine of x is equal to root 2 over 2. We want to figure out when is the y-coordinate positive root 2 over 2. So because we're looking for a positive y-coordinate, we're only looking in quadrants 1 and 2. And if you look, we should get pi over 4 as one of our angles. So we're going to write x is equal to pi over 4. And then remember, our denominator has to be the same, and we're looking in the second quadrant. So it has to be 3 pi over 4 as our other angle. That has a positive root 2 over 2 y-coordinate. So we get 3 pi over 4. So we get that x can be 7 pi over 6, 11 pi over 6, pi over 4, and 3 pi over 4. Let's go through some more examples. So for number 4, we have 2 cosine squared x minus cosine x minus 1 is equal to 0. And for this one, we're going to have to factor. So I'm going to use u substitution. You don't have to. If you can just factor this the way it is, go for it. But some students have a hard time factoring with trig value or trig functions, so we're going to use what's called u substitution. So we're going to let u equal the cosine of x. So our equation is going to become 2u squared minus u minus 1 equals 0. And now we want to factor this. So I'm going to factor using guess and check. You can also factor using the x method, but this one is pretty easy with guess and check in my opinion, so we're just going to do it like that. So we know that we have to have a 2u in one of our first spots and a u in the other. And now our second two numbers have to multiply to -1. So one's going to have to be a positive 1, one's going to have to be a -1. Put a -1 here and a positive 1 here. If you refoil this out, you will get 2u squared minus u minus 1. So we know that we factored correctly. And now what I'm going to do is replace u with the cosine of x because I substituted in u for the cosine of x earlier. So this is really 2 cosine of x plus 1 times cosine of x minus 1 equals 0. So that's basically how you factor our original equation. And now we're going to do what we did in the last problem, which is set each factor equal to 0 and solve. Cosine of x minus 1 equals 0. Let's solve the left one. Subtract 1 from both sides. So 2 cosine of x equals -1. Divide both sides by 2 to get that the cosine of x is equal to -1/2. And to solve the right equation, we're just going to add 1 to both sides to get that the cosine of x is equal to +1. Remember on our unit circle that cosine is equal to the x-coordinate. So if we're solving cosine of x is equal to -1/2, we want to know when is our x-coordinate -1/2. Since we're looking for a negative x-coordinate, we're only looking in quadrants 2 and 3. So we're going to get this point right here, which is 2 pi over 3. So we get that x is equal to 2 pi over 3. And remember, when we're looking in our third quadrant, we know the denominator of our answer has to be the same as the denominator we just got. So it has to have a 3 in the bottom. So we know that it's going to be 4 pi over 3. So this has an x-coordinate of -1/2. So our other angle is going to be 4 pi over 3. And now we want to solve the equation cosine of x is equal to 1. So we're trying to figure out where is our x-coordinate equal to +1. That's going to be one of our quadrant angles. So if you look over here, for 0 radians or 0 degrees, we are going to have an x-coordinate of 1. And that is the only time our x-coordinate is 1. So we're only going to get one answer from that equation. So we get x is equal to 2 pi over 3, 4 pi over 3, or 0. Now we're going to go through two examples where we've got multiple trig functions in each equation. So in example 5, we have 2 sine theta minus 1 is equal to the cosecant of theta. So this time we have a sine theta and a cosecant of theta. And we really can't do much with this unless we change one trig function into the other. So I like to work with sine and cosine more. So I'm going to turn cosecant into sine. So 2 sine theta minus 1, and I should say I'm going to turn cosecant of theta in terms of sine. So we know cosecant is 1 over sine. So we're going to write 1 over sine theta. And now what we're going to do is we need to get the sine theta out of our denominator. So we want to multiply both sides of our equation by sine theta. On the left, we want to distribute this in. So we get 2 sine squared theta. And we're going to have minus sine theta. On the right, think of this as 1 over sine theta times sine theta over 1. Cross cancel, we're left with a 1. And now we are going to move everything to one side so that we can factor. For the sake of time, I'm not actually going to go through the u substitution factoring for this one. If you guys want to pause the video and try that on your own, go for it. I'm just going to factor it as is. So it's going to come out as 2 sine theta. We'll put that in first. We know this has to be a sine theta. we're going to have a -1 here and a +1 here. So similar to our last problem. And now we want to set each set of parentheses equal to 0 and solve. So if we solve our left equation, subtract 1 from both sides first to get 2 sine theta equals -1. Divide both sides by 2 to get sine theta is -1/2. And for the right equation, we're going to add 1 to both sides to get that sine theta can also equal +1. And now remember that on our unit circle, sine is equal to the y-coordinate. So for this left equation, we're trying to figure out when is the sine of theta equal to -1/2. So we're only looking in the third and fourth quadrants because we want a negative y-coordinate. So we're going to have 7 pi over 6, and then we need the other angle in the fourth quadrant with a 6 in the denominator, so it's going to be 11 pi over 6. So we get that x can be 7 pi over 6 or 11 pi over 6. And now we need to figure out when is the sine of theta equal to 1. So when is our y-coordinate equal to 1? That's going to be one of our quadrant angles. So if we look up here, we're going to get pi over 2. And that is the only time our y-coordinate is equal to 1. So we get 7 pi over 6, 11 pi over 6, and pi over 2. Let's go through one final example where we have two different trig functions in one equation. So our last example is secant squared theta times tan theta equals 2 tan theta. So for this one, we're going to do something a little bit different than what we did last time. So because we only have two different terms, right? We have secant squared theta, tan theta on the left side, and we have 2 tan theta on the right, and they both have a tangent of theta in them. What we're going to do is get them to one side, and we're going to factor. So we're going to have secant squared theta times tangent of theta. We're going to subtract the 2 tan theta over to the left side of our equation. And now we're going to factor out a tangent of theta. So we're going to have a tangent of theta times secant squared theta minus 2 is equal to 0. And now it doesn't matter that we have two different trig functions because we have two factors that are being multiplied together. So we can set each factor equal to 0 and solve them separately. Then we have secant squared theta minus 2 equals 0. We don't have to do anything to the left equation. For the right equation, we want to isolate secant theta. We're going to start by adding 2 to both sides. So we have secant squared theta equals 2. Square root both sides to get secant of theta equals plus or minus root 2. And then I don't like to deal with secant. I'd rather deal with cosine or sine. So I know that cosine is the reciprocal of secant. So we can say cosine of theta is plus or minus 1 over root 2. Let's rationalize the denominator to get that cosine of theta is equal to plus or minus root 2 over 2. And then up here, let's remember that cosine is our x-coordinate and tangent is y over x. So let's do the cosine first because I think it's a little bit easier. So we're trying to figure out where cosine is positive root 2 over 2 or negative root 2 over 2. So when is our x-coordinate positive root 2 over 2 or negative root 2 over 2? So we're looking in all four quadrants. So if we look in quadrant 1, our x-coordinate is positive root 2 over 2 at pi over 4. So we get that theta can equal pi over 4. And now we're basically just going to take every angle that has a denominator of 4 because we're looking for angles in all three or all four quadrants for this one, but I'll show you guys on the unit circle. So again, we want to figure out where cosine is positive or negative root 2 over 2. So our x-coordinate can be a positive root 2 over 2 or a negative. So in the second quadrant, we get 3 pi over 4. And in the third quadrant, we get 5 pi over 4. And in the fourth quadrant, you probably guessed it, we get 7 pi over 4. So those are all of our answers for cosine of theta equals positive or negative root 2 over 2. And now we just have to figure out where tangent of theta is equal to 0. So remember, tangent is y over x. So we're trying to figure out when is y over x equal to 0. And remember, to make a fraction 0, you need the numerator to equal 0. So we're trying to figure out, when is our y-coordinate equal to 0? And if we look on our unit circle, our y-coordinate is going to be 0 at 0 and at pi. So we're going to get 2 more answers of 0 and pi. So we get 6 answers for this one, but we are finally finished. So hopefully this video helped you guys understand how to solve trig equations on the interval of 0 to 2 pi. If you want some more practice with problems like these, check out the link in our description for a free practice worksheet.